Hi, this is Tim Urdan, author of Statistics in Plain English, and today we're going to talk a little bit about z-scores. What is a z-score? Z-scores are used a lot in statistics, and they have a pretty useful function. What they do is they tell you what a raw score is in terms of standard deviation units. So there's a couple of different ways that we use z-scores, and there's a couple of different kinds of z-scores. So first, we sometimes use z-scores when we're looking at individuals, and the individuals can come from either a population or from a sample. And you can see in both of these examples on the top that the formula is really kind of the same. What's going on in the numerator is you're finding a difference between an individual score and a mean. And if it's a population, you've got a difference between the individual score and the population mean. And if it's from a sample, it's the difference between the individual score and the sample mean. So in the numerator, what you find is the difference between the individual score and the mean. And then in the denominator, what you have is a standard deviation. So what this does is it says, how far away is my individual score from my mean in standard deviation units? And that's what the z-score tells you. So that can be pretty handy. What you can get is positive z-scores or negative z-scores. If your individual score is below the mean, you'll end up with a negative z-score. And sometimes we want to know something like, wow, this person is, a standard deviation below the mean. And the one way that we use this is so that we can figure out, well, what proportion of students in the normal distribution would be that far away from the mean. Another kind of z-score is down here when we are looking at the difference between a sample mean and a population mean. So here you can see the formulas look pretty similar to the formulas above, except that now we're looking at the difference between a sample mean and a population mean. So how big is the difference between the sample mean and the population mean? And then the denominator, these are standard errors rather than standard deviations. So the resulting z-score says our sample mean is this far away from our population mean in standard error units. So pretty similar to main differences that we're looking at. Sample mean differences from population mean differences here. So to see how z-scores are used to help you figure out probabilities, that the probability of selecting an individual from a population that is this far away from the mean, or calculating percentile scores, things like that. Check out the next lesson and I'll explain how to do that using the normal distribution.